Hello, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Aziz bin Muhammad Syarif as a group leader for this problem misleading PBI report for engineering mathematics course, which is code DAM13303. So, let's move on to the introductions. So, the importance of this problem extends beyond their immediate applications. In the catering scenario, accurately predicting the cooling time of the soup can lead to better time management and resources allocation in a busy kitchen environment. In the medical context, understanding the decay rate of drugs like hydrocodone bitatrate is fundamental for developing effective treatment regimens and improving patient care. So, as you know, we got a task to solve the real life problem, which is for part A, we got the question 2, and for part B we got the question 3. So the objective of this project is twofold. First, we aim to determine the length of time required for a container of hot soup 82 Celsius to 50 Celsius in a room with constant temperature. This will involve applying Newton's law of cooling to analyze the cooling process. Second one is we seek to calculate the remaining amount of hydrocodone bitatrate in the body after 12 hours given its half-life. This will be achieved by utilizing the principle of exponential decay. Through this project, we will explore the practical application of mathematical modeling in both culinary and medical field, demonstrating the relevance and utility of this principle in everyday situations. Now, let's move on with the problem statement. So, for the question 2, part A, a container of hot soup need to be cooled from high temperature to a serving temperature in a room with a constant ambient temperature. This cooling process allows Newton's law of cooling, which states that the rate of cooling is proportional to the temperature difference between the object and its surrounding. The scope for this question is analyzing the cooling time of hot soup using Newton's law of cooling to ensure that the soup reaches a safe and desirable serving temperature within a specific time frame. So, for the question 3, part B, hydrocodone bitatrate, a common cough suppressant, exhibit a decay pattern where its quantity decreases at a rate proportional to the amount remaining in the body. Given the drug's quantity reduced to half its original dose in 3.8 hours, it is necessary to determine the remaining amount in the body after 12 hours. The scope of the problem is calculating the remaining concentration of hydrocodone bitatrate in the body after given a period which is 12 hours using the principle of exponential decay.
Assalamualaikum warahmatullahi wabarakatuh. My name is Dr. Masakim. My number matrix is AA232103. I'll be taking my part in the presentation for the part filler tables. So basically, for question 2 part A, the problem was about you help your auntie with a catering business before you serve a soup to a guest. So your auntie asked you to cool down the soup first before serving it. So in a room temperature that was about an 18 degrees Celsius, and the soup cools down from 82 degrees Celsius to 50 degrees Celsius in 6 minutes. So basically, you need to determine the length of time taken for the soup to cool down from 30 degrees Celsius to 22 degrees Celsius. So in these tables, you can see the facts about the room temperature, the initial temperature of the soup, the temperature after 6 minutes, and the target cooling of the soup. The issue is to determine the cooling constant, which is K, and to find the time needed for the soup to cooling from 30 degrees Celsius to 22 degrees Celsius. And the learning goals for it is to use Newton's law of cooling. You can see the formula there, and to derive K from the given cooling data. And the action is to solve K using the initial cooling data, and also to calculate the required cooling time using the derived K. Next, moving on to the second filler tables, which is question 3 and part B. So basically, the problem is about a cough supplement. So After the drug is fully absorbed into the body, the quantity of the drug in the body decreases at the rate proportional to the amount left in the body. After 3.8 hours, the amount of hydrocodone or the supplement left in the body is half the original dose taken, which is usually 10 mg. So the problem is, what is the amount left in the body after 12 hours? So in that tables, you can see the facts is the original dose was 10 mg. The amount left after 3.8 hours was half of that, which is 5 mg, and the target for it is the remaining dose that left in the body after 12 hours. So issues is to calculate the decay constant K and to determine the remaining amount of drug after 12 hours. And the learning goals is to use the exponential decay model. You can see the formula, and also to derive K from the half-life information. And the action taken was to solve K using the half-life data, and also to calculate the remaining drug amount after 12 hours using the derived K. And I think that's all for my part. You can, my friends will take the next part.
So my name is Nushada binti Abdul Rosli, matric number AA232314. So I will talk for the discussion part. Okay, so for the discussion, the proposed solution for predicting the cooling time of hot soup involve applying Newton's law of cooling. We state that the rate of change of temperature of an object is proportional to the difference between its temperature and the ambient temperature. By utilizing the given data that the soup cooled from 18.2 degrees to 50 degrees Celsius in 6 minutes, we calculate the cooling constant. With the constant, we found that the soup will take approximately 9.5 minutes to cool. Next, to determine the remaining concentration of hydrocodone bitartrate in the body over time, we use the exponential decay model, which describes the process where the quantity of a substance decreases at a rate proportional to its current amount. We calculate that approximately 1.11 mg of the drug will remain in the body after 12 hours. This prediction aids in understanding the duration for which the drug remains effective, which is crucial for proper dosage scheduling. Nonetheless, the reliability of this result is dependent on the assumption of a constant decay rate, which may vary due to individual biological factors.
Assalamualaikum, my name is Nashkim Mantinur Muhammad, matrix number 88230166, and I will present to you the last part of the presentation, which is conclusion. So, this project explored the application of mathematical modeling to solve practical problems in both culinary and pharmacology contexts. By persuading Newton's law of cooling and the principle of exponential decay, we address two distinct scenarios, which are cooling a container of hot soup and determining the day of hydrocodone bitartrate in the body. Okay, firstly, the summary of the finding in question 2, part A, are by using Newton's law of cooling. We calculate the cooling constant based on the given data, which is the soup cooled from 82 degrees Celsius to 50 degrees Celsius in 6 minutes in a room of 18 degrees Celsius, and with the determinant of cooling constant, we predict that it would take approximately 9.5 minutes for the soup to cool from 30 degrees Celsius to 22 degrees Celsius in the same ambient condition. As we include the implication of findings for it, the ability to accurately predict the cooling time of hot soup enhance kitchen efficiency and food safety. Knowing the exact time required for cooling allows better planning and resource allocation during busy periods, ensuring that food is served at the optimal temperature. This predictive capability reduces the risk of serving food at unsafe temperature, thereby preventing potential health hazard and improving guest satisfaction. Next, for the summary of the finding in question 3, part B, by applying the exponential decay model, we establish the decay constant for hydrocodone bitartrate. Given that the drugs amount half every 3.8 hours, using this decay constant, we determine that after 12 hours, approximately 1.11 mg of the original 10 mg dose would remain in the body. As we include the implication of finding for it, we understanding the decay rate of hydrocodone peptide in the body is crucial for effective dosage planning. Healthcare professionals can use this information to schedule doses more accurately, ensuring sustained therapeutic level of the drug while minimizing the risk of side effects. This finding contribute to personalized medicine by allowing for tailored treatment plan based on the patient-specific pharmacokinetic profile, ultimately enhancing treatment efficiency and patient safety. In conclusion, the application of mathematical models such as Newton's law of cooling and exponential decay provide valuable insight and practical solution in diverse fields. By accurately predicting cooling time and drug decay rate, we can improve process in both culinary and healthcare settings, demonstrating the significant impact and the utility of this mathematical principle in real-life scenario. That's all from me. Thank you.